Hey guys, we are looking at a system of equations here. I have 3 equations and they each have 3 variables. Now I want to figure out what I can plug in for x, y, and z that will work for all 3 of these equations. But how do I do that? Well, in this video, I'm going to show you 2 different strategies. We're going to do substitution and then elimination. If you want more in-depth examples on either of these, I will link some videos in the corner for you. All right, the first thing I always like to do when I am solving systems of equations like this is I like to number my equations. It just helps me keep them straight. I'm going to be moving these around, manipulating them a little bit. So I want to remember where everything comes from. All right. The next thing I want to do when we are doing substitution is I want to pick a variable and get it by itself on one side of the equal sign and everything else on the other side. So you can pick whichever one you want. Personally, I like to pick one that doesn't have anything in front of it because it's just one less step for me to do. So you can pick whichever one you want. I am going to pick this y right here. I want to get it all by itself on one side of the equal sign. So to do that, I need to subtract this 3x. If I do it from this side, I got to do it to the other side of the equal sign. I also want to get rid of this negative 3z, so I'm going to add 3z to both sides. So then down here on this side, all I'm going to be left with is y equals, and then on the other side, I'm going to write the x first. So I'm going to have negative 3x plus 3z plus 22. And then I'm just going to write a little reminder for myself that this is equation 2. These are equal to each other. I just moved this one around a little bit. So if I come back later, I'll know, oh yeah, that was number 2. All right, the next thing I'm going to do is I am going to plug this y in to the other 2 equations. I'm going to plug it in right here and right here. That's going to make it so in both those equations, I only have x's and z's left, all right? I'm not going to plug it into this guy because I'll just end up with like 0 equals 0, but I am going to plug it into 1 and 3. So I'm going to make a little note for myself so I know what I'm doing. I am plugging 2 into 1, okay? These little notes help me. If they don't help you, you don't have to write them. All right, so I am taking number 1, x minus y. But remember, I figured out in this system, y can be equal to this. So we are subtracting this whole thing as y. So I'm going to use parentheses to make sure we know we're subtracting the whole thing. So negative 3x plus 3z plus 22. So that's my y. That's what I'm subtracting. Then plus 2z equals negative 7. All right, now I just need to solve this down. So normally I would do it's in parentheses first, but those aren't like terms, so I can't add them. But I can distribute this negative in. Remember, we can't think of this as like a negative 1. There's an invisible one there that I am distributing in here. So that leaves me with x. A negative times a negative 3x is going to give me a positive 3x. A negative times 3z is going to give me negative 3z. Negative times 22 gives me negative 22. Then I still have plus 2z equals negative 7. All right, now I need to combine like terms. So I've got x and 3x, which are like terms. So that gives me 4x. And then I've got negative 3z and a positive 2z. When I combine those, I get a negative z. Then we've got the minus 22 equals negative 7. All right, now I want all my variables on one side, my numbers on this side, so we kind of look like these guys up here. So all I need to do is just add 22 to both sides. So then I have 4x minus z equals negative 7 plus 22 is 15. Whew! Okay, guess what? We are going to call this equation A. All right. Next, I plugged the y from number 2 into 1. Now I need to plug it into 3. So I am plugging 2 into 3. Okay, so here's 3. I've got 2x plus 2y, but we are plugging in this for y. So I've got negative 3x plus 3z plus 22. There we go. That's my y. Plus z equals 11. All right. Now I can distribute this 2 in just like that. So I'm going to end up with 2x. 2 times negative 3x is going to give me negative 6x. 2 times 3z is going to give me a positive 6z. 2 times 22 gives me 44. And then we still have the plus z equals 11. All right, now we're combining like terms. So I've got 2x and negative 6x, which is going to give me negative 4x. I've got a 6z and a z, which is going to be 7z. And then plus 44 equals 11. Again, I want my variables on one side, my numbers on the other. So I'm going to subtract 44 from both sides, which leaves me with negative 4x plus 7z equals negative 33. Whew! Did that feel like a lot of work? It kind of was, but we are getting very close. And we're going to call this equation B. All right. Now, why do we care about this A and B? What are we going to do with these guys? Well, I'm going to show you. First of all, I'm going to rewrite them up here. All right, here are those two equations that we got from plugging y in to 1 and 3. And we are calling them A and B. Well, guess what I get to do now? Now I get to get one of these variables alone and plug it into the other one, just like we did up here. All right, so looking at this, I see that z, even though it's negative, it doesn't have like a 2 or a 7 in front here. So I am going to try to get this z by itself. Okay, so in order to do that, I'm going to just rewrite it down here really fast again. So to get that z alone, first I'm going to subtract 4x from both sides, which will leave me with negative z equals negative 4x plus 15. But then I don't want to know what negative z is. I want to know what z is. So I can multiply by a negative 1 on both sides, which is just going to change everybody's signs, right? So I'm going to end up with z equals 4x minus 15. All right, guess what? I have my z. I'm going to label this with an A, just to remind myself that this is still A, just moved around, multiplied, things like that. But that is still A. So now I get to take this z and plug it in right there. All right. Again, I don't want to plug it into this one. I'll get 0 equals 0. But I'm going to plug it into B. So when I do that, I'm going to make myself a note. What are we doing? We're plugging A into B. So here's B. Negative 4x plus 7 times z. But I'm going to plug this in for z. 4x minus 15. And that is equal to negative 33. Guys, if this feels like a lot, we're almost to what x equals, okay? So what I'm going to do first, I'm going to distribute this 7 in. So I get negative 4x plus 7 times 4x is 28x. And 7 times a negative 15 is negative 105. I did that with a calculator earlier. I didn't just do that in my head, but we could pretend I did. And that equals negative 33. All right, combining like terms, I've got negative 4x and 28x, which will give me 24x minus 105 equals 33. All right, I'm trying to get x by itself. I want to know what x equals. So we're going to add 105 to both sides. It's just a two-step equation now. So I end up with 24x equals negative 33 plus 105 is 72. I'm almost done. We're going to divide that 24 on both sides. So I end up with x equals 72 divided by 24 is 3. Guess what, guys? X equals 3. Well, now that I know what x equals, guess what? I can plug it in either here, here, or even I could plug it in here and figure out what z equals. Okay? Like I said, I can plug it into A, into B, or into this modified A and figure out what it equals. I'm going to plug it in here because guess what? Z is already by itself. So what am I doing? I am plugging X into A, right? This one. So I'm going to get Z equals 4 times X. Guess what? We figured out X is 3. Minus 15. All right. So when I do that, Z equals 4 times 3 is 12 minus 15. And 12 minus 15 is a negative 3. Guess what, guys? That's what Z equals. Z is negative 3. Now all we need is Y. So you probably guessed it. We can take our X and Z, plug it in, and then we'll figure out what Y is. I could also plug it in here because remember that's number 2 just moved around a little bit. So plug it in, plug X and Z into whichever one you want. I personally am going to pick this one because, again, Y is already by itself. So what are we doing? We are plugging X and Z into number 2, right? So here we go. I've got Y equals negative 3 times X, which we figured out is 3, plus 3 times Z, which we figured out is negative 3, plus 22. Okay, so I've got Y equals negative 3 times 3 is negative 9. 3 times negative 3 is negative 9. And then I've got plus 22. Negative 9 minus 9 plus 22 is going to give me 4. Whoa. Guess what, guys? X, Y, and Z. You will sometimes see it written, the answer like this, X, Y, Z. It's like an ordered pair, but it has 3, so it's not a pair, but I don't know what it's called. Sometimes you'll see the answer like that. The cool thing is you plug this in for X, Y, and Z in all of these equations, and it will work for all of them. If it doesn't, you must have done something wrong. All right. Okay, that was substitution. Next, we are going to do elimination. And if you stuck around this long, I'm glad you did. And you'll probably be glad you did because guess what? Elimination is faster. So let's go ahead and do this. All right, so for elimination, the first thing I'm going to do is still to number these equations. so I can keep them straight in my head. Now, similar to substitution, I want to get rid of one of the variables, so I only have two I'm dealing with. So we're going to do that, but in a different way than we did with substitution. So I want you to look at this for a minute. Pretend number 3 is not here for a minute. We still care about you. You'll be back. But can you see, if I were to combine these equations, would you see? Do you see how the negative y and y would cancel out and I'd just be left with x's and z's? So that is really what I want to happen. So that's exactly what I'm going to do. I'm going to take equation 1 and equation 2 and combine them together. So I'm just going to write them over here really fast. There they are, and I'm going to combine these. Now I can do this because it's a system of equations. Let's see what happens. I've got an x and 3x, which gives me 4x. Negative y and positive y, which cancels out. That's what I wanted, so the y's are gone. 2z and negative 3z is going to leave me with a negative z equals negative 7 plus 22 is 15. All right, I'm just going to rewrite this without that big space where the y was. So I've got 4x minus z equals 15. And I'm going to name this, you probably guessed it, A. All right, so I got rid of a y, so I only have x's and z's left. Now I'm going to do that again. I just can't do it again with 1 and 2 because I already did it with 1 and 2, right? So I can either do it with 1 and 3 or 2 and 3. Use those equations to get rid of y again. So when I look at these, I notice with 1 and 3 that if this were a negative 2y, it would cancel with that 2y if I were to combine them. But it's not a negative 2y, it's just a negative y. But can I make it a negative 2y? Well, I can. And the way I can do that is to multiply this one by 2. Now, if I do it on one side, I got to do it on the other side so that it stays balanced, right? So as long as I do it to both sides, I'm good. So let's see what happens when I multiply that 2 in, distribute that in. So I have 2x minus 2y plus 4z equals negative 7 times 2 is negative 14. All right, so what is this? This is equation number 1 still, but I multiplied both sides by 2. Still the same equation. It's still balanced, but I multiplied it by 2. That's to remind me if I come back later and I'm like, where did that come from? All right, now I am going to combine that with equation 3. So I'm just going to rewrite equation 3 here. All right, there's equation 3, and now I'm going to see what happens when I combine these. 2x and 2x makes 4x. Negative 2y and positive 2y, yay, those go away. 4z and z gives me plus 5z. And negative 14 plus 11 would give me a negative 3. Now again, just rewriting this without that giant space there. 4x plus 5z equals negative 3. I'm going to call this B. All right, now what? Now I'm going to take these two equations. I'm going to rewrite them over here. And we are going to see if we can use them somehow, combine them, and get rid of another variable. So first, I'm just going to rewrite them up here. All right, there is our A and our B. Now I want to look at these and figure out what can I do to combine these to either get rid of the X's or the Z's. Now there's really two different things I can do. I notice these are both 4X's, right? So if one of them was negative, they would cancel out. I also noticed that the Z, one is negative, one's positive. So if this were a negative 5Z, they would cancel out. So really you can just do your preference. And even if you want to do the opposite of what I do and make sure we get the same answer, because we totally should, you can do that. So I'm going to choose to just multiply one of them by a -1, and then my x's will cancel. So I'm going to multiply both sides. I gotta do both sides to keep it balanced, and then distribute that -1 in, and I will end up with -4x plus z equals -15. Okay, now what is this? This is still a, but I multiplied by a -1. And then I'm just rewriting b. All right, now we're going to combine these. So -4x and 4x, leave me with no x's, sweet. Z plus 5z is 6z equals -15 minus 3 gives me -18. Look, guys, now it's just a one-step equation. I'm going to figure out what z equals. We're going to divide by 6 on both sides and get z equals -3. Yay! We know what z is. All right, now that we know z, it's way easy to find x, right? So I'm just going to plug in -3 for z somewhere. I can use a, I can use b, I can use the modified a if I want. I don't know. I'm just going to pick, let's just pick this one because z's by itself and positive. So we are plugging z into a. That's my little note to myself. So we've got -4x plus z, which happens to be a -3, equals -15. All right, so we could rewrite this just as -4x minus 3 equals -15. I'm trying to get that x by itself, so I'm going to add 3 to both sides. I end up with -4x equals -15 plus 3 is going to give me a -12. Then I divide by -4 on both sides, which leaves me with x equals -12 divided by -4 gives me a +3. Yay! I already have x. All right, it's real easy now to find y since I have x and z. I can plug it into 1, 2, or 3, whichever one we want. I'm just going to plug it into, I'm going to do this one. But again, if you want to do one of the other ones, make sure we get the same answer. That'd be fun. But I'm going to plug it into number 2. So, oh no, I said number 1. Sorry. I'm going to plug it into number 1. So we are plugging x and z into 1. All right, so x, we figured out is 3, minus y, we don't know that yet, plus 2 times z, which we figured out is -3. This is equal to -7. Then I've got 3 minus y. 2 times a -3 is going to give me -6 equals -7. When I do 3 minus 6, I get a -3. So I'm going to do negative y minus 3 equals -7. Then I'm trying to get that y alone, so I'm going to add 3 to both sides. Negative y equals a -4. But I don't want to know what negative y equals. I want to know what y equals, so I can just times by -1 on both sides, which switches my signs, so I end up with y equals 4. Guys, there's my answer. Okay, this was elimination. Let me find our substitution paper. Hold up. Same problem, right? This was substitution. We ended up with 3, 4, and -3. This was elimination. 3, 4, -3. Ended up with the same answer. This one took a little longer, was a little more writing, a little more work. This one was a little faster, especially when you're not explaining it and you can just do it. It goes a little bit faster. But hey, guess what? You can pick whichever one you like better. And remember, you always have the option to plug these in and make sure that your answer is right. That's what I would do if I were taking a test. I would do all the problems and then go back and start to plug them back in and fix any that might not work. All right, I hope this was helpful. I will link some more videos for you that I hope you'll check out if you need to. Thanks.